2025 Data Engineering Roadmap. There are lots of new tools and technologies coming every day, and it's confusing for people who wants to prepare for data engineering and start their career in data engineering. If you are someone who already have some experience in non-data related fields, or you are someone just out of college trying to enter into data engineering, this video is going to help you with what you need to learn to land a job in data engineering. Before we start with the roadmap, I would like to tell you at a very high level in one liner what data engineers do. Data engineers build and maintain the systems that collect, process, and store data so that it can be used for analysis, artificial intelligence, machine learning, and a lot more other workloads or use cases. And now I will be talking about the skills in order, and you may start learning in the same order. So I have structured this into four levels of skills: prerequisites, essential skills, advanced skills, and some optional skills. So the first thing to learn in data engineering is programming language. You can learn any one programming language among Java, Scala, and Python, but you are someone just starting learning programming language and confused on what to choose. I recommend Python because Python offers a wide range of libraries for all stages of data engineering, from data ingestion and transformation to building complex pipelines. Compared to other languages, Java and Scala, Python's syntax is simple to read, understand, and learn as well. Once you are good with programming language, then comes SQL. Data engineers frequently interact with various databases and data warehouses. SQL is the language that allows them to query and transform data within the databases or data warehouses. So data engineers need more than just basic SQL knowledge. You should be good at writing advanced, efficient, and optimized queries. It's going to be the core skill for data engineers and needs consistent practice to master SQL. And next one is Linux basics. So many cloud platforms, the data processing tools and frameworks are built and run on Linux systems. Understanding Linux commands and concepts is very crucial for interacting with cloud services and allows you to efficiently work with these tools and troubleshoot issues within these environments. You just need to learn the basic Linux skills that help you in file system, navigation, understanding permissions, and other Linux processes. These are the basic skills that are required before you start learning actual big data fundamentals. So basically, data engineers will deal with data at a scale. It would be in the volume of terabytes and petabytes. So it's important to understand the basic concepts of how this data is stored and processed. That's where distributed storage and distributed computing comes into picture. For understanding distributed storage, you need to learn the concepts of Hadoop. Hadoop is an open source framework designed for storing and processing massive datasets across clusters of computers. And for distributed computing, start learning Apache Spark. Spark is widely used framework for processing data at a speed, and Spark provides high-level APIs in languages like Python, Scala, and Java. You need to know one of these programming languages to work on Spark. So the Python or any other language you learn in the initial stages will help here. And Spark also provides Spark SQL, enables SQL-like queries for data manipulation and analysis. And you can use all your SQL skills and same SQL queries in Spark for data transformations. Once you are good at these above mentioned skills, then you can apply for entry level jobs in data engineering. But if you have some experience in other domains already and applying for mid level jobs, the mid level jobs comes with increased responsibility than entry level jobs. So you need to learn advanced topics that we are going to discuss now. So one important topic is Kafka and Flink for real time processing. So Kafka is basically a distributed event streaming platform for real time processing. Spark also has streaming capabilities and does the near real-time processing. So Kafka is basically a platform for efficiently transporting the data from various sources to different destinations. Once data is available at Kafka consumer end, we can use Spark streaming or Apache Flink to process that data further. Once you are good with these streaming tools, Kafka along with Apache Flink or Spark, you need to learn any one of the data orchestration platforms. So basically orchestration platforms automate and manage the complex data pipelines. So they basically provide a framework for defining, scheduling, and monitoring tasks within a workflow. So popular choices for orchestration are like Apache Airflow, Prefect, Dagster, Argo, and there are many more. So I recommend starting with Apache Airflow due to its large community, extensive documentation, and wide adoption as well. Once you know all these things, you should know where to implement or host them. Basically, the infrastructure is provided by cloud. You will need to familiarize yourself with any one cloud platform. There are three major platforms: Azure, AWS, and GCP. There is no dominance on one over the other. You can literally learn any of these. The underlying concepts and implementation remain the same irrespective of the platform, and you can replicate anything you learn in one platform in the other one as well. Now comes data modeling and data warehousing into picture. So data warehousing has become increasingly important in today's data-driven world. You will need to choose a data warehousing platform to learn and gain practical experience. Some popular data warehousing platforms available are Snowflake, Redshift, and BigQuery. While all three are excellent choices, Snowflake is a popular option because it's independent on any of the cloud providers and provides equal capabilities with all the cloud providers. So understand the concepts of data warehousing, like the core concepts of data modeling, schema design, data loading, then you should be good with the data warehouses. And then the last section and also the optional section. This is recommended for people who already have some experience in data engineering and looking to upskill themselves. So along with the all the above mentioned skills, you can learn the DevOps related skills. So infrastructure as a code is one you need to learn in the DevOps area, because this will basically allow you to build your infrastructure, change the infrastructure, and manage your infrastructure, everything in a safe, consistent, and repeatable way. So basically, you will be defining all your resources configurations, which you can version and reuse and share as well. So one tool that helps you achieve this in this space is Terraform. Basically, Terraform helps us manage infrastructure using code instead of manual implementations. So this is ideal for real life use cases where we have development, testing, and production environments. And the next one in this space is Jenkins, or a CI/CD tool. CI stands for continuous integration and CD stands for continuous deployment. Once you write your code or make changes in the code, these changes need to be deployed in corresponding environment. So Jenkins or Circle CI will help you with the same. So the next important tools are Docker and Kubernetes. Docker is a containerization platform tool, and Kubernetes is a container orchestration tool. So if you are writing some code and deploying it to any server, the server needs the same versions of libraries and modules that you are using for development. Using Docker and Kubernetes will ease the process of maintaining the same libraries across all the environments, and multiple developers can work on the same projects with the same set of libraries using Docker and Kubernetes. And the last but not least, think of an use case around you and implement end-to-end data pipeline covering most of these concepts to showcase the same in your profile and get some hands-on experience. That's it for this video. Remember that data engineering is an ever-evolving field, so continuous learning and adaptation to new technology is very important for staying ahead in the curve.